This application has 6 independent tabs built into, and each of the tab is designed to process certain kind of image specific function. The very first tab, we could select one image from our local file system. We have selected the image. When we load this image sets up as a default or the global image accessible by each of these tabs. In the very first tab, we resize our image based on our image height and image width, more height, more width. In the second tab, after loading the image, we could set this image as the grayscale image. In the next tab, we can take the same image which we have loaded here and split it all 3 channels, red, green and blue. In the next image, we are going to apply the alpha channel or the transparency to the image. And here, as you could see, that the transparency for the given image is either low or high. And in the very last tab, we actually add the scratch pad where you could scratch something, load that as a global image, and then you can actually apply that to all of these tabs. And finally, you can resize it. So that's the application we have built in this tutorial. Hello everyone, hope you all are doing very well. So you have already seen the final UI which we are going to build in this tutorial. This tutorial is designed to assist you creating multi-level user interface on top of your Python application by using the Gradio Python library. There are 2 big reasons I have created this tutorial. The very first reason, I just wanted to show you that even when the Gradio Python library mostly designed to generate the demos for your machine learning application by using the machine learning model. But in this tutorial, you will see that we are generating the multi-stage UI connected with very different function at each stage without using any of the machine learning application. And the second reason I created this whole tutorial so that you will have the final code in your hand, which you could embed in your existing Python application and can create the dynamic UI if that is your objective. So why you would need to use the Gradio at the first place? So when you are creating your application using the Python as your backend code, and you would want to add the user interface on top of your Python code, you have a few options available. One of the option is to use the Python Gradio library. Because if you are using the Python Gradio library, it's the fastest way for you to demo your Python code. To demo your Python code by adding a very simple web interface top of it, accessible from anywhere in the world. The way I have created this tutorial is that it looks like either hands-on lab or workshop where we are performing everything from scratch and we are adding our code as we progress by adding piece by piece or step by step functional component. So while completing this tutorial, you are definitely going to learn a lot more than just regular programming or the use of Gradio Python library or building the UI on top of your Python application. So I do have PyCharm open with image processor UI project, and the main.py just has the entry point for our Python application. The current runtime Python is 3.10. Our code is ready to run. I will just give a quick test. The code is running and hello world is printed here. So our next step is to import the Gradio. Gradio is already installed here. Import Gradio as gr, and we will be using the Gradio blocks in our project to build the UI, something similar to this, which we have already created in the introduction to this video. Gradio blocks are going to help us to build the UI, which is designed in multiple tabs, and each tab has the input and output functionality where we could select an image and we can process it. In the next step, while we are editing our main.py, we are going to create object. My app, you can choose whatever name you would want, and you are going to instantiate Gradio blocks. So my app object will be used to add the rows, columns, and the tabs, etc., whatever really needed in order to build our UI. Rather than adding all of our code into the main.py, we are going to create a new class and we will add all that code over there. So we are going to create new class image process UI. So this will be our class name and our file name will be image process UI.py. In this image process UI, we are going to create the class image process UI object. We will define our init. This class is going to have the entry point to this my app object. So we are going to use that UI object here, and this UI object will be used during the initialization of this class. So self.UI object will be the same UI object, this one. Next, we will create a new method where we are going to develop our UI application UI, very simple method. And here we are going to just use the Gradio component again. After we have created our main entry point, after the image process UI object will be instantiated, this is the method which is going to create the UI. So we are going to use this UI object. So with self.UI object, the very first step, just for a starter, we will add the markdown, and the last method is going to be launch UI. And in this method, we are going to just this UI object, which is created using gr.blocks, that is going to be launched. So we will be using self.UI object dot launch. So this is our very simple class image process UI. So we are going to import it. So from image process UI, we are going to import this class image UI is equal to, this is our image process UI. And whenever we are going to instantiate the class, definitely it's going to initialize itself. In the initialization, it needs the UI object. So we are passing this my app UI object. In the next step, we are going to call this create application UI. And finally, this is going to launch the UI. That's it. This sets up the object, this develop the UI, and this is launching the UI. We can run this code. Gradio app is running at port 7860. Here we only have the markdown in our application, and that's where our UI is. So the code in our main.py is just pretty much, it is going to be as it is. Most of the work we are going to complete here. So at first stage, we are going to create the very first tab, and within the tab, we are going to create a single row. That row is going to have the two columns. In the first column will have one component, and the second column is going to have two components. Here we will be using with gr.tabs with gr.tab item. The very first item will be select your image. So that's the place where user will select source image. So we need with gr.row. We need two columns. So with gr.first column. In the first column, we are going to have a component which will be our gr.image with gr.column. So this is our source image. So we will call it image source. So this object is image source. Here we will be adding, this is our image source. Second, we are going to create the gr label, and here will be the gr image, which is the output. input image, output image. This will be output label gr.label. This is image info, and another gr.image, so gr.image, and this will be our output image, image output, and that will be our img image output. So these are two columns. Now we need a button, so we can use button at this column label. Source image loader is our button, gr.button, and our button title will be load above image. At this point, our one tab is ready. We can give a quick try and let's see what we see here. After we relaunch the application, this is our very simple UI, which is similar to this first tab. Here we are selecting an image. Once image is selected, we will process this image by clicking here, and that image will go backend. We will collect the image information, we will render here, and the same image output will be rendered here. So once we have built this UI, now we need to launch it. So our very first button is source image loader. So at the application level, so this is the UI object. So we have to come at this point here, dot click, and the very first we need to have a function. So let's create a new function call define process source image, and image source will be used as the entry point. Before we process it, I'm just creating a very simple code, at least to get us going. So process source image will be the method which will be kicked when the click event is going to happen. For Gradio, you need input and output. So here will be the input parameters, here will be the output parameters. So whenever this button is going to be clicked, it is going to select these input component. So whatever is being selected here, and output will be generated by this method. So our input is image source, that's our input. Our output is going to be output label, first parameter, and image output is the second parameter. Let's come back to our code. It means whenever this method is going to process, it has to send us two output, some information as a text and image itself. I will go ahead and I will just add one text message here, image info and image out. Let's run this code. Now we have the click event added to our code. At this point, our application is running. Let's select an image, load above image. When we will click this method will launch this process source image. Image source is being used as an input parameter. Here is our output parameter, which is the image source, and some text message we have just added here. And that is what output here as a first parameter, and the same image is visible here as the second parameter. That is exactly what we have planned to build in this step. Now our next step is to complete this image info. In order to get the image info, the best option is that you could create a breakpoint here and debug your application. Our breakpoint hit. This is our image source. You can take this image source, debug it. Here you can get an idea that image source, you can see this is an ND array. So this is the NumPy array of size 2160, which is the height, width, and the number of channels. So here is the image shape. We can collect the image information here. So now we know that this is our image source. So you could say if image source is not none, we can make sure if the length of image source dot shape is equal to 3, because there could be 3 channel, and it is also possible that in some cases it will have only 2 channels by any reason. And we have also checked that first parameter was the height and second parameter was the width. So we could create an array, image info is an array, and here will be image info dot append. First parameter is the height, second parameter is the width, and the third parameter was the channel. If there are two parameters, then we have height and width only. And because this is the image info, we could use this as a first parameter. And when we are sending this first parameter, this is just a list right now. So before we send, we could convert that to a string. So second parameter, we didn't make any change. It is as it is without any further change. And the first parameter is text. Run this code, reload. Let's see what the problem could be. Set the breakpoint. So if you look into image source, as you see here that our image source is ND array. So we could validate if it is none, it is false. So we can use the same condition, and we can, if image source is not none, then this code is going to be executed here. Run again. At this time, there will be no error. 3 channels. Let's run it. Here is our information and here is our image. So based on our objective, this tab is completed. Now our next step is second tab, which is resize image. In the next step, we are going to create this resize image tab, and again there will be a row. Row is going to have the 2 columns. First column, we are going to have a label plus 2 slider. These sliders will have the control for image height and width, and depending on whatever height and width is selected, by clicking this image, you will be able to update the image size. So this one was the parent for our first tab. It means if we would want to create another tab, we will come back here at the same level and we will create another tab. Exactly. Here will be resize your image. We will have 2 columns. In the first column, we already had our label, resize label, gr.label, and we will have image height as a parameter, which will use gr.slider. Slider takes the first parameter, which is the lowest value of your slider. This is the highest value of your slider. Then we need to provide the label, image height, and the value here will be whatever your default value. So our value will be the 100. Similar to that, we are going to have the image width. So these are the 3 components in our left side column as shown here. So these 3 components. Now let's build the right side component, and we will use this button actually here. So that would be far easier to just make any change and click. So we will also add image resize button equals gr.button resize image, and our output will be very simple image output. And the only change here, the variable will be resized image output. So this is our second tab is ready. Restart our application again. Check our second tab. As you could see that our second tab is ready. If you would want to add a message here, we could add the message, because label has, that's our label, and that is our label message or label value. So we can actually add the value here. As you could see that there is no control built into, so that's why we do not see any action here, because we haven't built the control for our components. Now, similar to our source image loader action button in the first tab, we need to do exact same step for the second image resize button. Dot click. The first we need a method, define image resizer, which will take the image height, image width as the input, and return will be the image out and image out, where the image is going to come from. And that is where we need to learn a little more about the Python global objects. So first, when we load our image and we select our image, we need to make sure that the image which we have loaded is actually accessible for the second component. It means this method, which is loading your image at the very first tab, has to do something in the backend so that when this button is going to be clicked, this button has access to this image. So this is the method which loads this input image. So we need to make sure that the image which is being loaded has a global property. So we will create an object called image global, and we will define that image similar to what is our image source was. And if you remember, this was the numpy nd array. So we will use np. So we do not have numpy imported yet. So import numpy as np. Now we will create an image which will have all the values as zeros. So numpy.zeros, we are creating an image of size 10 by 10 by 3 channel, which is similar to image source shape. We are creating a global image which has all the values as 0, but the height, width, and the channels are 10 by 10 by 3. And the data type for this object is going to be numpy dot unsigned integer. So that's our image global. Now what we want is that we need to make sure that whenever this image source was processed, in this method we actually take and use the image global as our global image. It means what we can do, we can take this image global and we can set this image equals to our source image. And there is a warning. If you look into the messages, this method is actually shadowing the name image global from outer scope. So there is already image global is defined. Use the global keyword and you make this image global as global. Because of these two lines, now this image which you are going to select here will become the global image. So whenever we would want to resize, we could actually access this global image. It means that image out will be this image global, and then we can actually process the resizer operation here. So at least this way, our resize operation will have the entry point and the access or the hold to our source image. So let's validate that first. Let's relaunch our application. Before we launch, we need to complete this method. We forgot. So image resizer is our method. When this image resize button will be clicked, we need to have input. We also need to have output. Our inputs are image height and image width. So height is the first parameter, width is the second parameter. We make sure our inputs are exactly the same, height and width, and our output will be image resize output, which is the image. Let's run again. Application is started. Load this image that we have already seen. We can come here. As you could see, because a method is bind to our component, these components are active, we could actually set them. The maximum value is 1000, minimum is 10. Let's resize it. And as you could see that whatever the source image was, exact image has been rendered here. It is not resized yet because we haven't write any code in the image resizer method. So we have to resize our image. I will put a breakpoint here. Use the resize image click. We know that our image height and width has been entered here. And image global at this point, if you will see that image global is actually the numpy nd array. And nd array is just a simple three-dimensional matrix. So in order to process this as an image, we have to make sure that we can take this nd array and we actually process it as an image. So we are going to use the PIL library. So from PIL import image. So image class has all those methods which are going to be very useful for us. So whenever we are going to read this image global, we can actually take this image and we can say that image dot from array. And if you look into this from array, can take the ND array and convert that to the image. Once we have this image out, now we can resize it. We can resize this image by passing the image height and image width. And the way you enter these values as a tuple. So we need to put these values as a tuple, and now image out is going to be resize this image based on given parameter, and we need to take this and save it as an image out. That's all we really needed in order to set up the image resize method. Loading the image. At this point, let's run the resizer. Let me make width here. Now we know our width is 470, height is 100. Image global, as you could see, is ND array. Next, the image out is actually the fill image. It means we can run the resizer on top of it, resizer method with parameters that will generate the new image with resized height and width, and output will be available in the UI. Here is our image. If you would want to reduce the height, so looks like the parameter wrong. So let me fix that issue at resize, and we can actually click here. That will help us. The size is a tuple which actually takes first parameter as the width and second parameter as the height, versus we are doing opposite. So that's the error. Now our code is correct. Width, yes, as you could see that our code is working. And this code is also going to help you understand how you can run Gradio application with successive execution of your code, because you are combining the various interfaces. Right now we have 2 tabs in our application. So after this step, we have completed the first tab. We have also completed the resize tab. So our next step is to create the third tab, which is going to convert the image to grayscale. Once again, our objective is not to learn the image processing. Our objective is more focused on how to create the multi-tab app with Gradio and process it into a step-by-step serialized way. Let's build the third tab. In the third tab, we are just going to have one single column, which will have just as a label image detail and the output as the grayscale image. Copy this grayscale image as grayscale. Here we are going to have image grayscale button, grayscale your image. We are also going to have the image output, which is image gray output, and we can also have one more label here, which will say source image as grayscale. And if you want to add the value here, you can say grayscale image. So these are the 3 components which will be part of third tab, and when this button is going to be clicked, we will get the grayscale image output. We are not sending any input. Dot click. First we need to build the grayscaler image, so we will call this method image convert grayscale. Input will be simple, I'm just using LBL, which is just a label is coming. Our output will be the image out. Let's use the same code because we are taking the image global and we are processing it. This is our image out, which is the fill type of image. This method is going to be used here. Next, we need to pass the input parameters and we need to pass the output parameter. So our output will be image gray output. And input, if you see here that we are not defining any input because there is nothing is going to be input. And if we try to run this application, as you could see here, application ran because the input list is empty. So let's run the code. Our third tab is added. And as you could see here, that first is our label, second is the output will be here. If we click here, it's going to generate error because we do not have our source image selected yet. We have now source image is set. It means global image global object is instantiated. We can run a resizer. Our source image is still the same. Now we will click this button and we will see that if we could get the image back here. The error came. If we look into the error, you will see that this method is required positional argument. It means it's expecting the input parameter. If we say, okay, there is no input parameter, use the image global as input, we could bypass that. Let's run again. Here is our output image. It's not grayscale yet because we haven't processed yet. But in this scenario, as you could see, that we are not sending any input. We are only getting the output from this method in this tab. Let's come back here and we can figure it out how to grayscale it. So if you have experience with Pill Python library, there is a method called the conversion method. So if you will use imgout.convert, this method can convert image to various types of image. And as you could see here, the conversion operators are either CMYK, like a 4-channel, 3-channel RGB, or the L. L is a grayscale. It means if you would want to convert this image, you can say convert to grayscale and store the converted image into image out variable, and that's what is going to be used as output variable. Run the code. Here is our image, grayscale. Here is our grayscale image. Color and grayscale. Resizer is working. So now you could see these two tabs have their own method, and then they both are handling their own copy of the image which was loaded here. So that's the third tab we have created, and we have completed the code. In the fourth tab, we are going to take the same image which was selected in the tab number 1, and we will create 3 channels of the given image. Let's build the fourth tab now, and this tab will have the first row with just a 1 label, and the second row is going to have the 3 columns, and each column is going to have the label and the image. Let's build the tab. This will be image with red, green, and blue, so RGB channels. Column, so we will have a first row is going to have the 1 column, source image with channels, red channels. So this is our first column. We also need a second row, so second row with 3 columns. Label is nothing, and that will be the red channel. So this will be the RGB label, RGB red label, and then we need to have the image out, img red output, red channel. Second column is going to have this is the red, green, 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 and then third will be our blue, blue. Now we need to add a button. So we could add the button here at the bottom. So it will be at the row level. So we are adding here this button. So it will be image 3 channels button, show 3 channels in image. Let's take this button dot click. We need to add the first method, which will the show 3 channels input. There is no input, but output is going to have 3 different images, red, green, and the blue. Let's take this method and create a new method, define input. There is no input because we are going to use the same global image. That will be our image out. Now we need to make sure that we do have ability to split 3 different images out. So it will be img red img blue, img red, blue and green RGB. So these are the images has to be returned from here. So we can define, we can say that img red, img green and img blue, these all images are image global. Okay, so we have set these things up. Now we need to make sure that the image global which we are trying to process, this image global must be the image with 3 channels, because if the given image does not have the 3 channels, it will not work. So we could say if image global dot shape has the 3 properties, it means the length of image global shape is equal to 3, and image global dot shape, this third item, is equal to 3. It means there are 3 channels. Only this situation is true. It means we will have the 3 different channels of the images. There are so many ways you could actually process these images and you can extract the channels out. The one method which I am going to show you is really very simple. So first I will show you that let's define the red image. Okay, and this red image is actually the numpy dot zeros. So we are creating the image which has the same size as image global. So image global, remember, this is a 3-dimensional numpy nd array which is height, width and channels. So red image variable is filled with 0 and the size is exactly the image global. Now let's define the red channel, and you can find the red channel in the image global. If you look into 3-dimensional array, you can take first, second and the third property 0. Remember there are 3 channels, so 0 is the red channel. And now you take the red image which has all the 0, and in this red image 0, and this will be your red channel. So this is the numpy image now. So if you want to take this image red, you can convert the numpy array image back to the fill image format. So image red is equal to image from array, and take this red image here and make sure that all the values in the img red, because these values, they are the numpy unsigned integer, similar to we have set this way. So let's dot as type unsigned integer 8, and that's how we will get the red channel. Remaining image green and image blue, let's see what happened. Let's run this code now. So show 3 channel is going to be processed here when this image 3 channel button is going to be clicked. Rerun the code. This code is good. Grayscale code is working. Let's come back here. We could see that this is our header, 3 channels. Let's click here. There is an error. Let's look into the error in this method. Let's to here. Okay, np.zeros, error is there. I made a mistake here. It should be shape. This is the zeros will be filled on the shape of the image global, because here I was just passing whole nd array, but we don't need to pass the whole nd array. We need to pass the shape of the array that has to be filled and create the red image object. Load, launch. Okay, so that error has been passed. Now you could see here this image is filled with all zeros. Red channel image, if you look into here, we are selecting all the 0 channel and then we are setting it up. Now if you look into your red image, that is been only the 0 channel has the value, rest is all 0. So it means everything is going to be red. Here we are taking this this should be red image, this as type, and then it's become the img red. Yeah, that should be red image. That's another mistake. So this is we have just created for the red image. uint. Okay, this is the numpy.uint. That was the third error. Having error is not a problem as long as you know what you are doing. Perfect. So img red is our image. Let's check here. These two images have no operation. It's just as it is in versus out. Here we have full red image. Now we can do same thing to extract the green channel and the blue channel. Code will be very simple now. So we could take this same code. We could do for the green image, and this will be our green channel. So green image is here, that will use the green channel, and the image green here is going to use the green image RGB. So this will be value as 1 and 1 here. So RGB, and then we need to get for blue image, which is going to be blue image and its blue channel. Blue image is going to be img blue will be equal to processing the blue image RGB. Run again. If anybody has any problem understanding this code, just message me at YouTube video and I will explain you nicely there. But here, just in nutshell, we are first creating all the zero filled image, then we are extracting the image global, only the red properties, and rest green and blue. For every channel, other two channels will be 0. So only R, either R or G or the blue values are coming out from the image global. Rest is all 0. Let's see. RG blue image. Oh, I forgot to make 2. RGB. Our grayscale is still working, resizing, all working. So these 3 tabs which we have created after loading our image, they all are working. In the next step, we are going to add the alpha channel, which is the transparency of given image. If the transparency is not available in the channel, we will add that to it, and then we will use the slider to move the transparency or the alpha channel value that will result the transparency or the alpha channel setting directly in real time in our image. Let's add the tab for our alpha channel. In the UI, we need one single row with one single column, and the column is going to have one label, one slider, and the image out. So slider value will be used as the input variable, and the output variable is going to be the image out. And we do not need to have the click event built into, but we will definitely use the click event to start with, but then later we will add the update support as well. Use this code. Image with alpha channel. We have one single row, one single column, alpha channel button. This is just a label, so we can use here alpha channel label. We have button, we need a slider, so let's take a slider. The slider value is alpha channel value, and this value will be between 1 to 256, and the default value should be 128. So these are the 4 component. Let's use this image alpha channel button dot click first will be the alpha channel handler. So process alpha channel. And this will have the alpha channel value input. That's our method input, and the output. Input is going to take the alpha channel value. Output is going to generate the image output. So whatever our image global variable was, or the image stored into the global object, is our image out. Next, in the image out variable, the fill Python library already had something called a method put alpha, and this put alpha actually takes the alpha value and it can set up the alpha channel for the given image. And if you look into the put alpha, you see that this is returning null. That's why we don't need to return the output of this value into image out. We can just use it as it is, and that's all it really takes. Method put alpha, that should be enough for us to get it working. Let's run the code. Image load, channels are working, alpha currently 128. If we put more value, as you could see that there is definitely transparency built into. Much better if we try to go lower. So you can see that very simply we could have add the alpha channel support to the given image using Python PIL library, because that gave us the method to add the alpha channel support. However, we want to make this dynamic. Means when we change this value, we don't need to click the button. It means we need to have the update event handled in the slider itself. So let's implement that. If we look into our control is image alpha channel value. Means take this value and we can update directly here. So there is a method called change. So this change method is going to use same way as the button click event. Same method has to be updated when there is a change in value. So that's okay. The inputs going to be the alpha channel value, and the outputs is going to image out, this image. That's all. And you need to make sure that you are sending this as a list. You are not sending just as a variable only. You have to make sure this way it's correct. Let's rerun the code. Image loaded. Here is our alpha channel to start with, but after that go back. As you could see that update event is built into. That's all was needed. So now we have 5 tabs implemented based on our requirement. Now we just really need to build the sketchpad tab. So the sketchpad tab is just a very simple component named sketchpad. So let's implement the sketchpad. Image with sketchpad, and it has 2 columns, left and right. In the left column we need to have the image sketchpad, which is the source, gr dot, if you look the component is sketchpad, label will be draw your image, the output will be the img sketchpad out gr dot image scribbled output, and the button we can use left side here, pad button equals gr dot button. That's all we really needed. Let's take this sketchpad button dot click. First is the method, image process sketchpad and the input value is coming the scratch image. So what we need to do is that whenever the scratchpad image is coming, we can take this and that will be our image out. Let's start from here, and output is the image. Image process scratchpad is our method, comma, the input, comma, the output. The input is img scratchpad image source. The output is this image. Let's compile and run our code. Here is our scratchpad. We can right click, here is image, cancel, say, circle. As you could see that whatever we are doing in scratchpad is available. However, if you reload your image, that is not going to be changed here, because we are not setting our global variable to the scratchpad image, because that scratchpad image is also going to be the same image which is being sent by the scratchpad. So if we would want to set this image as the global, the only thing we need to do is that we need to use this code. That's all we need to add. It means adding it here. Now the scratch image became the global image, and that code will be enough for us to solve our objective. Let's take a scratchpad here. Now if you see here, it's using the scratchpad image. You can see you can make it bigger, height, width. We can grayscale, which is already, we can look for channel. This image is having no channel because when we were creating this image is actually does not have any channel. And how we can prove it? We can prove by using the breakpoint here. If you look into a scratch image, this is 28 by 28 with no channels. It's simple ND array, black and white. See here, this simple 28 by 28 shape with no channels are added. Because of that, this image does not have any red, green and blue channels visible here. So that's how we have implemented all 6 steps in our project related to image processing. The code related to this project is located at DeepWorks GitHub repo in developers program folder, and the project is Gradio tabbed UI with this image processor UI Python application, exactly the same as we have used in our demo, and both main.py and the image process UI.py are available here. So that's all I had for you in this tutorial. I hope you have enjoyed the content and learned something new. I do appreciate your time, and I'm looking forward to seeing you in my next video. Until then, thank you so much.